Okay, everybody, welcome to Unit 5. Here is our first lesson in Unit 5 called Graphing of Quadratic Functions. So as you know, last semester we spent the entire unit learning how to do quadratics through factoring. This unit is going to be continuing that work, but we're going to be looking at it through graphs instead of through factoring. So let's talk about a quadratic function. The parent graph, or the original graph of the family of quadratic functions, is the very simple y equals x squared. Graphs of quadratic functions have a general shape, and we've spoken about this in class before. It's called a parabola. Now there are two different ways that a parabola can present itself. It can open upwards. If this happens, we say it has a minimum point. And that kind of graph is one that looks almost like a smiley face. So it's opening upwards and it has a minimum point. The other type, and that's when the value of a is positive. And don't forget, a comes from the standard form of a quadratic, which is ax squared plus bx plus c. We used that standard form a lot last semester. So if the value of a is a positive number, you end up with a smiley face parabola, or one that opens upward. Conversely, you'll have a parabola that opens downwards if it has a maximum point and the value of a is negative. And not too surprisingly, what that looks like is this, and we can call it a frowny face. Sounds kind of childish, but that's kind of an easy way to remember it. So a frowny face parabola comes because you have a negative value of a and it has what is known as a maximum point. A smiley face parabola is one that opens upwards and it has a minimum point. So whether you're going to be a smiley or a frowny depends upon that value in front of the x squared term. So let's have a look at a couple of graphs before we do our own examples. So if we look at example 1 here, you will always have a table of values. Sometimes it will be given to you, sometimes you have to complete it. Remember, a table of values is quite simply giving you a bunch of ordered pairs. And when you take those ordered pairs and put them onto a graph, they're going to create the parabolic shape. You will be often given the x values and you have to find the y values yourself. To do that, you're going to be substituting the x values into the quadratic equation that will be given to you. Then the y values will come out and you will take those ordered pairs and graph them in as smooth a curve as possible. That's harder than it looks. We're going back into the language that we used way back in Unit 1 in first semester when we were talking about the domain and the range of graphs. Remember, domain is the x values contained in the set and the range is the y values contained in the set. So if we look at the graph above, this graph up here, I hope that you can see that the domain is the x-axis and there's no limitations on that. It's continuing infinitely in both directions to the left and the right of the x-axis. So the domain is what we would call all real numbers. That's something we've spoken about in class before. Now the range is the y values and if there are any restrictions on them. So if we look again at the graph above, if we look at the y-axis, you will see that the graph goes infinitely up the y-axis. However, it does have a limitation here. Let me just change to red so you can see what I'm doing. Here it is, here. It doesn't pass below this point. Remember, this parabola has a minimum point, and that point is at 0, -3. So that means that the range can be all real numbers as long as they are greater than or equal to -3. And as I said at the beginning of the class, that's called its minimum point, so it cannot go below that point. So the second example over here to the right is an example of, once again, a quadratic in standard form, but look at the value of a this time. The value of a this time is a negative, which makes me, hopefully you guys will remember now we're going to have a frowny face parabola. So there are a bunch of x values given. You substitute these x values into the quadratic and it will spit out the corresponding y values. And then what you have once again is a bunch of ordered pairs, and each one of those pairs gets put on the graph. There we go. And then as smoothly as possible, you're going to draw a curve through that so that it creates a beautiful looking parabola. And then we ask those same questions again. What is the domain and what is the range? So once again, the domain, the x values are continuing infinitely, both to the left and the right of the x-axis. So the domain is all real numbers once again. This time, if we look at the y-axis, go back into red. Remember, if we look at the y-axis here, now I can see that there is a limit on my y values. It does not go beyond this point. This time it has a maximum point, and that maximum point, what is that? 1, 2, 3, is at 0, positive 3. So the y values, or the range, can be any number, all real numbers, as long as they are less than or equal to, oh gosh, was that a 2? Yep, that was a 2, not a 3, sorry. Less than or equal to positive 2, and that is called the maximum point. Okay, so that's the basic language we use when we speak about parabolas. So your biggest job, your main job, is to look at the original quadratic and see whether or not the value for a is going to create a smiley parabola or a frowny parabola. Then the rest is up to you. You're going to fill in the table of values and talk about the domain and range. So let's do one on our own now. Use a table of values and graph each function, and then tell me about its domain and range. So I filled in a few x values. We've spoken about this in class before. Remember, as long as you have a nice mix, some positives, some negatives to the left and right of 0, we should have a nicely balanced parabola. So we're going to begin by substituting the x values into the equation and then getting the corresponding y values. Actually, the first thing I'm going to look at, though, is the value for a. Have a look at the value for a. Remember, there is a 1 in front of the x squared, and it's a positive 1. So I know that the value for a is positive, which means I know that my parabola is going to come out looking like this. Okay, that just gives me a heads up before I start doing all the math that goes with it. Okay, so let's put our first x value is -2. Let's substitute that into the given equation. I'm just going to do my working for this one. This can be done on your TI, but I'm just going to show you, because a few of you have made mistakes with negatives in the past, so please be careful. Remember, you have to type it like this. You have to put the -2 into a bracket and square it to tell your TI that you want the entire value to be squared. And then we're going to add 2. So what's going to come out here is positive 4 plus 2, and then obviously, oh, sorry, getting ahead of myself there, 4 plus 2, and then we get the answer y equals 6. So that y value corresponds with that -2. Now you please show your working for these, because these questions can be worth quite a lot of marks on a quiz or a test. Just to save time today, I'm just going to fill in the answers. If I put a -1 in there, I end up with 1 plus 2, which is 3. If I put a 0 back into the equation, it's very simple. I'm left with just 2. If I put a 1 in there, I'll have a 3. 2 will produce 6, and 3 would be 3 squared, which is 9, plus 2, which is 11. So remember, this table of values produces the all-important list of ordered pairs. So I have 3, 4, 5, I have 6 ordered pairs that I'm now going to go over to the graph on the right-hand side and plot them. So when x is -2, so 1, 2, y is 6. 1, 2, 3, 4, 5, 6. So there's my first point. When x is -1, y is 3. When x is 0, y is 2. When x is 1, y is 3. 2 is 6, and then 3 is 11. My graph doesn't have space for that, so this is enough. But when I look at the graph, I can see already that I haven't made a mistake, because it has made a nice little smiley face shape. So now, as smoothly as possible, I'm actually turning my laptop. I'm turning my iPad. I don't even know if you can see that. I'm going to, yikes, try and join them as smoothly as possible. Don't forget to put your arrowheads, and there we have it. So if you remember the notes from up above, your parabola will either have a maximum point, by that means a point it can't go higher than, or it will have a minimum point, which means it doesn't have a point, it has a point that you can't be below. So I'm hoping you guys can see that this point here, right here, I'm going to turn it into a green one, that point is 0, 2. that is the lowest that my graph can go. That is its absolute minimum point. So just remember that for future questions. All I've asked for here, though, is your domain and range of your graph. So my domain, once again, is going to be all real numbers because it continues towards the left and the right with no restrictions along the x-axis. My range is on my y values, and there is a restriction on my y values, sorry. It cannot go below +2. So y can be any number that is greater than or equal to +2. So there is my domain and my range. All right, so now I want you guys to try one on your own. So the next one, if you turn the page, is y equals -x² subtract 4. I want you to pause the video, and I want you to take out your TIs, and I want you to fill in the table of values. I want you to draw the graph and then write in your domain and range. And then I want you to start the video again and check the answers that I have on the next page. But please try and do it yourself first so you can see how much you understood from this example. Pause it now. Okay, so now you should be starting again. This is a really good test of listening skills. You went off, you did your own work, and this should be what you produced. You should have noticed that the value in front of x², so the a value is negative, so you should have been expecting a frowny face or a downwards facing parabola. I chose a nice mixture of negatives and positives. I put them into my TI and I got my ordered pairs. Your domain should be all reals, and this time your parabola had a maximum point at 0, -4. Over here I labeled it on the graph. So that helped me figure out my range. My y values could be anything on the y-axis. Oops, I made a mistake there. As long as it is equal to or less than -4. Okay, so I hope you pause the video. Don't just copy this. Make sure that you can do it yourself. Okay, turn the page. So this page has got quite a bit of vocabulary, so bear with me, because what we're going to do now is take it to the next step. That was the basic graphing of a parabola that we just covered, and the domain and range was something we did last semester, so it should have sounded familiar to you. Right now I'm going to introduce a couple new vocabulary terms to you. Let's go. Symmetry and vertices. Parabolas have something known as they have a geometric property called symmetry. You've come across that word in elementary and middle school. You know that it means if you take a figure and you fold it in half, each half will match the other half. They are identical. So if you can imagine a dotted line down the middle of a parabola, so if I scroll down and look at this graph that I'm putting an asterisk next to right now, if you could put a dotted line down the middle of a parabola and fold it, the two halves would match each other perfectly. That's because parabolas are symmetrical. So that's a really useful property for us. That vertical line, that imaginary line down the middle, has a special name, and that's called the axis of symmetry. The axis of symmetry. And within that axis of symmetry will be your minimum or maximum point. Remember, each parabola has one of those. And that minimum or maximum point is actually called a vertex. So every parabola has a vertex, and every parabola has an axis of symmetry. So the axis of symmetry actually has its own special equation. And that equation is right here in this box here. This equation right here, x equals -b divided by 2a. That is the equation for the axis of symmetry. Why do we need it? Because sometimes we are asked to describe a parabola, and one of the things you'll be asked to describe will be the axis of symmetry, remember, which is where is the middle? Where is the exact middle of this parabola? And this is the equation we use. Now, the -b and the 2a are not just random variables. Remember, they come from the standard form of a parabola, which is over here in the green box I'm making right now. ax² plus bx plus c. The b and the a that are in this equation come from the standard form of the parabola. So x is equal to -b over over 2a. All right, so here's a partially worked example. I've left some of them blank, and we're going to fill it in together. So here we go. Consider this graph. So we've got 2x² plus 4x plus 1. So take a moment here and actually label the a, the b, and the c. So we know A is positive 2. You can see that B is positive 4 and C is positive 1. It's really important you put these in standard form so that you have them all in the correct place. So here are some examples in red of the kinds of questions you're going to be asked about a parabola. I'm going to ask you to write an equation for the axis of symmetry. I'm going to ask you to find the coordinates of the vertex. Remember, the vertex is just the maximum or the minimum point of the parabola. And then, oh, there we go. Question C will then ask you to identify whether that vertex you found was a maximum or a minimum. And then the last question is quite simply graph it, now that you've got all of these properties. So let's begin. If this is the equation and somebody is asking me to find the axis of symmetry, I need to substitute the value for A and the value for B into the equation that I just learnt for the axis of symmetry. So x is equal to negative b over 2a. So on the next line beneath that, I'm going to substitute. I'm going to keep the negative right there. And in place of b, I'm going to put the value for b, which is positive 4, over 2 times the value for a is positive 2. So I end up with x equals negative 4 over positive 4, which of course simplifies to negative 1. So the equation for the axis of symmetry is x equals negative 1. So remember, that is a so-called imaginary dotted line that goes right down the middle of a parabola. So this negative 1, if you come down to the graph again, if I put an asterisk, here I am over here, look at the dotted line. There it is, right down the middle. And notice that it passes through x equals negative 1. That is the folding line, or the axis of symmetry. Okay, next question. Question B. Find the coordinates of the vertex. In other words, where does this parabola turn and go back in the opposite direction? So once you have the axis of symmetry, which in this case was negative 1, to find the coordinates of the vertex is a substitution problem. You substitute that negative 1 into your original equation, and you simply find y. So I'm just going to zoom in a bit here. So here's our original equation. Here it is, y equals 2x squared plus 4x plus 1. I now replace every x with the negative 1 that I just found in the axis of symmetry. And now I do the math. So this would be 2 times negative 1 times negative 1 is positive 1. 4 times negative 1 is negative 4 plus 1. And then I just simplify from left to right. I have positive 2 subtract 4, which is negative 2, plus 1, and I get the answer negative 1. So that was the y value I got when I substituted in the x value of negative 1. So there it is right there. I'm going to change to pink. The vertex of my parabola, remember the minimum or the maximum point is negative 1 comma negative 1. They're not always the same number, you guys. That's just a coincidence. The vertex can be any ordered pair, of course. So if I go back down to that asterisk one more time, there it is, that exaggerated pink point there. The turning point, or in this case the minimum, is at negative 1 comma negative 1. And then question C says identify whether that vertex you just looked at is a maximum or a minimum. I think it's quite obvious from that graph now that because the x squared term is positive, the parabola will open upwards. Remember, a smiley face parabola opens upwards, which means the vertex will be a minimum point. It's a minimum point. And then lastly, you just graph the function. And to graph the function, you simply use a table of values. And that's it. So let's put it into action. That's a very colorful looking page right now. Make sure you're copying all of this into your notes so you can use it to help you with your homework. Okay, so let's have a look at number 1 together here. Consider each equation. Determine whether you are looking at a graph that will have a maximum or a minimum value. Give me that maximum or minimum value as an ordered pair, and then tell me the domain and the range. Okay, and also find the equation for the axis of symmetry and graph the function. Phew, that's quite a lot to do. Okay, so if I look at that equation. What is it? Y equals x squared plus 3. I'm just going to zoom in here to look at this equation. Remember, there is a 1 in front of that x squared. So I'm going to make a little list on the side here just for me. I'm going to make a list that says a, the value of a is a positive 1. The value of b is actually 0 because there is no middle term. And the value of c is a positive 3. I'm also going to make a note for myself here that because a is negative, because a is positive, then I know I'm going to have an upwards facing parabola, a smiley face parabola. Those are just mental notes that I'm making. Now I'm going to go down and make a table of values. I cheated a little bit, I went ahead of you guys. And again, I'm just choosing a range of negative and positive values. Please use your TI, okay, or be very careful with your mental math. I'm going to substitute these x values into the equation. So negative 2, if I put negative 2 back into this equation, it's negative 2 squared, which is positive 4, plus 3 gives me 7. If I put the negative 1 in, negative 1 squared is 1, plus 3 gives me 4. 0 is always nice and easy. If I put the 1 in, 1 squared plus 3 gives me 4, and 2 squared is 4, plus 3 is 7. So mental math is fantastic, but use your TI to check your work, okay? Remember, the purpose of this is to get a whole bunch of ordered pairs. So let's go from our table of values, let's go straight to the graph before we answer the questions that were asked. Let's start there. So when x is negative 2, 1, 2, 3, 4, 5, 6, 7, y is positive 7, negative 1, 2, 3, positive 4. When x is 0, y is 3, 1 is 4, and 2 is 7. Can you see how the almost mirror images the points because of the axis of symmetry of a parabola? Because you can fold it exactly in half, you can see that the points are the mirror image of each other. Now we're going to try and draw the smoothest curve we can, as neatly as possible. Don't forget your arrowheads. Okay, so straight away I can see that my parabola over here has got a minimum point, so a point that it cannot go below. I can see that straight away, and I can see it is at 0, 3. So now let's go to the list of questions we were asked. Number 1, does this parabola have a maximum point or a minimum point? Definitely has a minimum point. What is the value of that minimum point? In other words, at what point on the grid does the graph turn? And it's at 0, 3. My domain, nice and easy again. The x values continue infinitely in both directions, so it's simply all real numbers. My y values continue infinitely up the y-axis, so as long as they don't go beneath positive 3. So anything greater than or equal to positive 3. And then the last thing they want is me to work out the axis of symmetry, which, remember, is that imaginary dotted line that goes right down the middle. Now, in some graphs, it's very obvious. You can see straight away what the axis of symmetry is, and you can actually see it's right there. It's on the y-axis. If it's not obvious, which happens quite often, all you have to do is do a very quick equation. So x, remember the equation for the axis of symmetry is x equals negative b over 2a. And then you do a quick substitution. Go back to your original equation. What was the value of b? It was 0. So we got negative 0 over 2 times the value of a was positive 1. So I have 0 over 2, which gives me 0. So my axis of symmetry is x equals 0, which means it's the y-axis. The axis of symmetry is actually right on the y-axis. That's where I would fold my parabola in half. So now I think I'll do one more with you, and then I'll let you do the next one on your own. So let's turn the page, please, and let's try the next graph together. All right, number 2. So this time the print is quite small, but the first thing I want you to do is identify the values of a. So there's a is negative 1. B, there he is. B, is negative 4. And C is negative 4. Okay, so keep those in mind. Also remembering if A is negative, hopefully by now you know that your graph is going to do this. It's just a good thing to keep in mind when you start graphing so you can see if you've made a mistake or not. Okay, so let's begin by filling out our table of values. So on your TIs, of course, now remember we've got 3 terms here, so you need to take a little more care when substituting. I wonder if minus 4x minus 4, because I know where this graph is going to, I think we might want to begin with negative 4 with this one. So let's change this to negative 4, negative 3, negative 2. So taking a little bit of artistic license here. Here we go. So we'll use negative 4, negative 3, negative 2, negative 1, and 0, just because I'm looking at the grid that I've given you guys, and this graph is going to be over quite far to the left. Okay, so pick up your calculators and let's put negative 4 into this equation. So it would be negative 4 squared, which would be negative times negative 4 squared, remember? So it will look like this. Negative times negative 4 squared. Subtract 4 times negative 4. My goodness, this is a lot of 4s. Subtract 4. So that gives us negative 16 plus 16 minus 4. So if you put that into your TI, you'll get the answer negative 4. Please use brackets, okay? And then you should feel a little more confident getting these answers. If you put negative 3 into that equation, it will give you the answer negative 1. If you put negative 2 in, you'll get 0. Negative 1 will give you negative 1. And if you put 0 in, it'll give you negative 4. Okay? All right, let's go over and plot that on the graph. When x is negative 4, y is negative 4. So 1, 2, 3, 4. 1, 2, 3, 4. Here we go. When x is negative 3, y is negative 1. When x is negative 2, y is 0, so there it is right there on the x-axis. Negative 1 goes with negative 1, there's that mirror image happening again, and 0 with negative 4. So now as smoothly as you can, use your pencil and draw in the smoothest curve you can. Oy, better than mine, I hope. There we go. Okay, so hopefully what you can see there is this one has a maximum point. So the graph will not go higher than this point. And that point is at when x is 0. Excuse me, when x is negative 2, y is 0. All right, so now let's go and answer the questions that were asked of us. Number 1, does this graph have a maximum or a minimum? Definitely has a maximum. What is the value of that maximum? There it is right there on the graph, negative 2, 0. The domain, the graph continues infinitely left and right, so it's all reals. The range is any y value, as long as that y value is equal to or below 0. Now, the axis of symmetry, remember, is sometimes visible. So I'm actually going to go, I can see it quite clearly that this would be, watch where I draw my dotted line. Right, there it goes. There is my imaginary folding line, and that's at x equals negative 2. Now remember, if that wasn't obvious to you, or if you get a graph in your homework where it doesn't fall nicely on a line, you don't have to guess. You're going to use this equation, x equals negative b over 2a. And then you substitute in the value for b, which in this equation was negative 4, over 2 times the value of a was negative 1. So we end up with positive 4 over negative 2, and there we get the answer, negative 2. So either the axis of symmetry will be obvious to spot, or you may have to do a little bit of algebra to get to it. But either way, it should be straightforward for you guys. Okay, so number 3, I'm going to do the same thing now. I want you to pause the video. Don't go ahead. Really try and do these on your own. Create a table of values. Use your TI, find the missing y values, draw the graph, and then fill in the questions, as we've just practiced in question 1 and 2. So pause the video now and test yourself. So for those of you who were listening and did actually pause the video, now you should be coming here just to check your answer. So here's number 3. This is what you should have been doing on your own. I went in and I did the table of values, and then I'm going to now plot them. So when x was negative 2, 2, 3, y was 3, negative 1 was 2, 0, oh gosh, what on earth have I done here? All right, here we go. When x was negative 2, y was 3. 1, 2, 3. When x was negative 1, y was, I have made a mistake here. Oh boy. Y was 2, 0, and 3. What have I done? All right, hold on 1 second, guys. So negative 2 would give me 4, and then that would be positive 4 minus... What on earth have I done? Give me 1 sec. Negative 2 gives me positive 4. So positive 4 minus 4, so that one's correct. Okay, and then if I put negative 1 in there, that gives me positive 1 minus 2, which gives me negative 1 plus 3, which gives me 2. That one's right. 0 is 3. 1 plus 2 is 3. 4 plus 4 is 8 plus 3. Okay, why on earth do I have this? X is negative 2, y is positive 3. And x is negative 1, y is 2. X is 1, 2, 3, 4, 5. Oh my goodness, I'm really not sure what's happened with this graph, you guys. I will redo this part of the video and get it back to you. But for now, I'm not sure what's happened with this graph. This should work out really, really nicely. But because I have all the answers here for your minimum and your maximum, I really don't know what on earth happened there. This should have worked out nicely. And I'm not sure what's happening. So I'm going to have to go and have a look at that, because the table of values is correct. I've just maybe the grid. Maybe I've played with the scale on the grid. Anyway, never mind. Look back at question 1 and question 2, and those are worked out perfectly, and they work nicely for you. So they'll give you a good example of what you need to do, unlike question 3, which is not working for some reason. All right, let's move on to the word problem so you can get on with your homework, and I will get back to you about that question 3. Okay, word problem. A juggler. So a juggler is tossing a ball into the air. The height of the ball in feet can be modeled by the following equation. So this equation should look familiar to you. We did quite a lot of these type of motion equations back in Unit 4, just before the December holiday, where we had, people hitting balls up into the air or people throwing rocks off mountains. Remember, they always began with this negative, with the 16. So now what we've got is a juggler who's throwing the ball up in the air. So let's use that equation and answer the questions that follow. Question A says, at what height is the ball actually thrown? So this is at the beginning of the juggler's, I don't know what, of his trick, of his show, right? But no time has passed. This is the first time he throws the ball into the air. So if we're looking back at the equation, we've got a bunch of x's, and y represents the height and x represents the time. So by them asking you at what height is the ball when no time has passed, that means they want you to take the equation, and everywhere there is an x, they want you to put a 0. Okay, so negative 16 times 0 squared plus 6 times 0 plus 5, because no seconds have passed, so x is quite literally 0, and that ends up being y equals 5. So that's a nice simple. So the height at which the ball is thrown is y equals 5. So then the second question wants to know, what is the maximum height of the ball? Now listen to that word. That's the language we've been looking at this lesson. Maximum is the turning point of this parabola. Now think in reality, somebody throwing a ball up in the air, whatever goes up must come down. So this is going to be a downwards facing parabola. We know it's going to look something like this. And this question is asking you to find this point here. What is the maximum height? So to find that, we need to find the axis of symmetry. Okay, we need to find the axis of symmetry. So, to find the axis of symmetry when you don't have a graph, remember you quite simply use this simple friendly equation, negative b over 2a. So x is equal to negative b. So I go back, I'm just going to switch to red pen and I'm going back up to the equation where this question came from. B is equal to positive 6 and a is equal to negative 16. So negative b is going to be a negative outside and a 6 inside over 2 times the value for a is negative 16. Which means if I switch back, I now have x equals negative 6 over negative 32. And if you put that into your calculator, because that isn't really a realistic answer when we're talking time or seconds, if you put that into your TI, you should get 0.1875. So 0.1875 is the time the maximum height of the ball will be reached after 0.1875 seconds. Okay, so now remember, once you have the axis of symmetry, you substitute that back in. And that will give us, so we had y equals negative 16, and then in place of x, I'm now going to put 0.1875. You know, fancy changing my colors here. So negative 16x squared plus 6 times, and now let's put the value for x in, 0.1875, close bracket, plus 5. Okay, and if you put that in, now you should put that into your TI exactly the way it is presented on the screen right now. Okay, and then if you type it in, you should get this answer, 5.5625. Now remember, those two answers are not separate. What they create is an ordered pair, and that ordered pair is the vertex, right? The vertex, or the maximum point, is equal to 0.1875, 5.5625. Close the bracket. So that's your vertex. So now if I just draw, I'm just going to switch over to black, I think. If I draw a little sketch, I know I'm going over the page here. I think you guys will have space though. So I've got height here on my y-axis. Here's my height. And I've got time here on my x-axis. So remember, we said in question A, at what height is the ball thrown? The ball was thrown at 5 feet, so approximately here. Then it went up and it came back down, of course. And also it does come over here, but that's not realistic. We don't go back in time. So the question was, what is the maximum height of the ball? In other words, what is this height right here? So to do that, we had to work out the axis of symmetry, and we found out that the axis of symmetry, which is this imaginary fold line down the middle, was at 0.1875 seconds. That's what's happening here. And then we substituted that back into the equation, and it gave us 5.5625, which gives us this y value here, which kind of makes sense. So if the juggler released the ball at 5, was it feet? I think, not meters. Yep, he released it at 5 feet. It got as far as 5.5 feet, and then it started falling back to the ground. And that's why that parabola makes sense. So the numbers aren't pretty, but it's realistic according to the graph. So that's that. That is today's lesson on graphing quadratic functions. A couple of tips: make sure it's always in standard form. Look back over the, I will come back and revisit question 3 with you when I get back to school. I'll try and figure out what happened there. But let's go back through question 2. Look at the kinds of questions I can ask you: max or min, domain or range, table of values. It's mostly about vocabulary today. So please review the vocabulary before you start today's homework, and I will see you next class.